Hey everybody, and welcome to this video on the coordinate plane. So let's get to it. So consider the following function named f, and we've got 6 input-output pairs listed already, but there are definitely more of them as indicated by this ... at the end, but these are the ones we can see for now. And so the question we have is, can we predict the output to this function when the input is -3? Now, apart from ordered pairs, there are some other ways we could represent this, including a mapping diagram or a table of values, or perhaps you could even come up with an equation to describe the relationship. But that would be pretty hard. So sometimes it's important and helpful to be able to represent these input-output pairs more visually or with a picture. That can sometimes give us more insight into the relationship between the quantities we're discussing. So this brings us to our next way of representing functions, which is graphically. So how do we represent these graphically? Well, so what we've got here is a horizontal real number line and a vertical real number line overlaid on top of one another. In general, our horizontal line typically represents all of our inputs. And it's helpful to let the reader know that by labeling that horizontal axis with an X or perhaps the word input. Typically, the vertical axis represents all of our outputs, and it's helpful to let the reader know that by labeling that Y or writing output. Again, you could use whatever variables you want as long as the reader knows which one is the input and which one is the output. So how are we going to represent the input-output combination 2 and 5? So when 2 is the input to this function f, 5 is the output to this function. Well, let's look at our horizontal axis, our input axis, and we can find the input 2. Let's draw a vertical line right there. So this vertical line represents all the input-output combinations that are possible that have an input of 2. Okay, let's find 5 on the output axis. There it is, and let's draw a horizontal line there. That horizontal line represents all the possible input-output pairs where the output is 5. Now, look, there's a place where these two lines intersect. And if we draw a point right there and get rid of these lines, that point right there lines up with 2 on the input axis and 5 on the output axis, and that means that for this function, the input 2 goes with the output 5, and we represent that with just a point. Okay, let's try doing another one. How about the input-output pair 4 and 9? When 4 is the input, 9 is the output. Well, similarly, we're going to find 4 on our input axis, we're going to find 9 on our output axis, and we're going to draw a point right there where the input 4 goes with the output 9. And that point represents the input-output combination 4 and 9. One more time. How about the input-output pair -4, -7? We're going to find -4 on the input axis. We're going to find -7 on the output axis. We're going to draw a point right there, and that point means that for this function f, the input -4 goes with the output -7. So we still have 3 more ordered pairs to graph, and I hope you're getting the hang of it, so why don't you try graphing these on your own? So if you'd please pause the video, please graph these remaining 3 input-output pairs on these axes, and if you'd label them too, that would be great, and when you're done, please play the video and we'll reconvene. So now that we've graphed these 6 input-output pairs, it appears that they make a pattern. All of these input-output pairs lie on a line. So let's go ahead and connect them with a line. And now that we've done that, this allows us to make a pretty good prediction of what the output will be when the input is -3. It appears that the output should be about -5. Well, can we use this to predict the input to this function when the output is -9? Absolutely. Let's find -9 on the output axis, and it appears that the input that goes with that should be -5. So just goes to show that being able to draw a picture of these input-output pairs graphically might really help us understand a little bit more about the relationship. All right. A few more things about our graphs and the coordinate plane. The point 0, 0, right in the middle, where the horizontal axis intersects the vertical axis, is called the origin. This is a very important point, and it comes up all the time. Now, you can see that from our axes, our input-output pairs are loosely divided into 4 regions. The 4 regions of the coordinate plane separated by the axes are called the quadrants. The upper right hand is called the first quadrant, the upper left hand is the second quadrant, the lower left hand is the third quadrant, and the lower right is the fourth quadrant. Note, the first quadrant is going to get a lot of attention because both the input and the output are positive there. When we're modeling real-world situations, oftentimes we're working with numbers that aren't negative, like distance or time, so we use this first quadrant a lot. Alright, let's practice a few. So here is the function g, and here are some of its ordered pairs, and what we need to do is we need to graph these ordered pairs and use them to predict what the output will be when the input to this function g is -4. So why don't you pause the video, graph these 8 ordered pairs, and when you're done, unpause the video and we'll reconvene after predicting what the output will be when the input is -4. Now, with these points in front of us, do you think you can predict what the output will be when the input to this function is -4? Well, it appears that our points make a general U shape, and in fact, it almost appears to be symmetric right about where the input is -2. And if that were the case, then if the input to this function were -4, then the output should be -5, right there. In fact, this shape right here is called a parabola, and the equation for this function is y equals x plus 2 quantity squared minus 9. I didn't expect you to know that at all. It's something we'll discuss a little later, but I thought I'd put it on your radar. Alright, one more quick practice. Here's a function named h. Here are 5 ordered pairs that go along with h. Why don't you please graph these ordered pairs on the axes provided and use them to predict the output to this function when the input is -8. So why don't you pause the video, do that, and when you're done, unpause and we'll reconvene. Alright, so after graphing those 5 ordered pairs, it appears that our points lie more or less on a line, and if we extend that line, we can predict that when the input to this function is -8, the output should be 9. Alright, now that we've had some practice making graphs, let's try reading some graphs. So here on the axes, we got a function named Bob. We've got some input-output combinations represented graphically. So what we need to do is find Bob of 4, Bob of -2, Bob of 2, and Bob of 0. For each of these, that means please find the output to this function when the input is 4, -2, 2, or 0. Alright, so if the input is 4, let's just find 4 on our input axis, it appears that our output is 8. We have the ordered pair 4, 8 right here, so we say that the output would be 8. Bob of 4 is 8. Let's try Bob of -2. Let's find -2 on our input axis, and it appears that the output is -5. We've got the ordered pair -2, -5 right down here. So we'd say that Bob of -2 is -5. How about Bob of +2? Well, let's find +2 on our input axis. And you know what? It appears that there is no point for which 2 is an input. It's just not part of the function. So what we'd say here is that this function Bob is not defined for an input of 2. The only inputs it appears it can have are -6, -4, -2, 0, 3, 4, 6, and 8, but not +2. So what we say here is that Bob of 2, it's not defined, it's undefined. And last but not least, Bob of 0, here's 0 on our input axis, and it appears that the output is -3. Here's the point 0, -3, and so Bob of 0 is -3. Here's a fun one. If Bob of r equals -3, what are the possible values of r? So what we're saying is, if the output is -3, what are the possible inputs? So let's just find -3 on our output axis, and it appears that there are 3 different inputs, each of which have an output of -3. An input of -6 has an output of -3, an input of 0 has an output of -3, and an input of 8 has an output of -3. So I'd say R could be -6, 0, or 8. So let's say if Bob of X is -7, what are the possible values of X? So we say if -7 is the output, what are the possible inputs that give that? Well, let's find -7 on our output axis, and it appears that we've got no points there. There are no inputs that ever give an output of -7. -7 is just not part of our output set. So we just say none. There are no values of X that give -7 as an output. All right, last one. On the right, on those axes, we've got the picture of a function named g. The big difference here is that g is kind of one continuous curve as opposed to a whole bunch of different points, but we're going to approach it in exactly the same way. So the first thing we want to do is find g of -2. That is, find the output when the input is -2. So let's find -2 on our input axis and see where our graph is there. And it appears that our graph is around -5. Here's the point, -2, -5. And so we'd say that g of -2 is -5. Which inputs have an output of 4? So let's go ahead and find 4 on our output axis and see if there's a point there, and there is, and it appears that for an input of -5, we have an output of 4. Here's the point, -5, 4, and so we just say -5 is the input that has an output of 4. If g of d equals -2, what are the possible values of d? What we're just saying is, if -2 is the output, what are the possible inputs? So let's take a look. Let's find -2 on our output axis and see what the inputs could be. And it appears we've got 1, 2, 3 different points for which -2 is the output. And it appears that the inputs could be -4, 0, and +4. So the possible values of d are -4, 0, and +4. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.